Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Acid, Bases and Salt 10 Cbse. Let's see today's topic. So last time we have seen how to determine acid and bases by using litmus paper, phenolphthalein and methyl orange. The change in color depicts the difference between acid and bases as such. Today we are going to see how to use the olfactory indicators. What are these olfactory indicators? Means you can smell and you can make out between acid and bases as such. Right? Okay. So there are some substances whose odor changes in the acidic or the basic medium as such. So what we need to do? We need to take some finely chopped onions in a plastic bag along with some strip of clean cloth. Right? Take chopped onions in a plastic bag. Right? Along with that, you take strip of cloth with that. Okay, tie up the bag tightly and leave it overnight in the fridge. So onion is there in this and you keep this in the refrigerator. Okay, the cloth strips can now be used for the test of the acid and bases. Remove this and the strips we can use for this test now. Okay, so now take these cloth strips and check their odor. You need to check their odor. So what you will see that you'll get the onion smell on this strips. Now keep them on a clean surface and put a few drops of dilute hydrochloric acid on one strip. Okay, the first strip, right, take some drops of hydrochloric acid on it and a few drops of sodium hydroxide on another one. Okay, right. Rinse the cloth strips with water and check the odor again. You rinse them in water and check. Now let us note down the observation. What we see is that the odor of onion cloth vanishes in sodium hydroxide. You won't feel the odor of onion on this cloth which has been applied sodium hydroxide. The odor remains unchanged on this hydrochloric acid cloth. Alright. So this is the odor change we can find out on the cloth strips. Okay. Now let's see another way. Take some dilute hydrochloric acid solution in one test tube and dilute sodium hydroxide in another. Okay, take two test tubes. Right, take two test tubes. In one, take dilute hydrochloric acid. Another, take dilute sodium hydroxide. Okay, add few drops of vanilla essence into it. Okay, add vanilla essence into both. Okay, and shake well. Now check the odor once again and record the change in the odor. The odor of vanilla essence vanishes, right? Okay, here you see that vanilla essence odor will vanish in what? In this test tube which contains sodium hydroxide. The odor of vanilla remains like that only, unchanged in hydrochloric acid. Okay, similarly, if we take clove oil, right? Test the change in the odor of clove oil with the hydrochloric acid dilute and dilute sodium hydroxide. What we see is that the odor of clove oil vanishes in sodium hydroxide and it remains unchanged in hydrochloric acid. So these are the olfactory indicators. By smell, we can differentiate between acid and a base as such. Now let's see how do acid reacts with metal. Right. Let us see the reaction of acid with metal. What will happen? Okay. For this, what we are going to take? We are going to take 5 ml of dilute sulfuric acid. I am going to take dilute sulfuric acid. Okay. In a test tube and add few pieces of zinc to it. Right. Zinc granules to it. Then what will happen is that what we see is that hydrogen gas bubbles are seen on the zinc granule. Okay, so hydrogen gas is released. Pass the gas being evolved through a soap solution. The gas, which is hydrogen gas, which is evolved, right? We are passing it to what? Soap solution. Okay, now why these bubbles are formed? The soap bubbles are filled with hydrogen gas, right? Okay, the soap bubbles are filled with hydrogen gas. Now, if you take a burning candle near the gas filled bubbles, what you observe? Hydrogen burns with a pop sound. Okay, this is a confirmatory test for hydrogen. Hydrogen always burns with a pop sound. If we repeat this activity for hydrochloric acid, right, or nitric acid or acetic acid, what we are going to observe? We are going to observe that zinc reacts vigorously with strong acid. With strong acid, it will react vigorously, right? It also reacts with weak acid. So acetic acid is what? It is a weak acid. But the hydrogen gas is liberated very slowly, right? So hydrogen gas is liberated slowly in this case, right? So let us see the apparatus, how the arrangement is there. Here you will see that the test tube is there. In that you have got the zinc granules is there, and then you have put H2SO4 dilute in this, right? Okay, then what happens? See, the delivery tube is there, and here you see what happens is that the hydrogen gas is liberated. The soap solution is there, okay, and you'll see that the hydrogen gas is liberated. The soap bubbles filled with hydrogen will be there, right, and you'll see the pop sound will be there. Okay, so now the reaction of zinc granules with dilute sulfuric acid is like this. Okay, so what we can write down, the general reaction: acid reacts with metal to give salt plus hydrogen gas, right? Okay, so in this case what it was, it was H2SO4 reacts with zinc. So what I will get? I will get what? Salt. What is the salt? That is my zinc sulfate plus hydrogen gas is released. Right, here you see two hydrogen on both the side, zinc and zinc, one sulfur, oxygen and oxygen is there. So the reaction is also a balanced chemical reaction, right? So the general is what? Acid reacts with metal. Acid, it reacts with metal to give me what? Metal, salt and hydrogen. So we have seen here how the metal reacts with acid to give salt and hydrogen gas. Now let us see how what are the reactions of bases with metal as such. Okay, for this what we are going to do? Again, we are going to place a few pieces of granules of zinc, right? Zinc metal in a test tube, and we are going to put what? 2 ml of sodium hydroxide to it. Okay, now some gas will be evolved. We are passing down the gas evolved the same way what we did in the case of acid. Okay, here you see the soap bubbles are coming, and we are tasting these bubbles with what? With candle, and you'll see that the burning of hydrogen gas with a pop sound will be there. Okay, past the gas being evolved through the soap solution, taking a burning candle near the gas filled bubble. So what here we see here is that the reaction that takes place can be written as what? Sodium hydroxide is there, NaOH plus zinc, right? What we get is, we get sodium zincate. Okay, we are getting sodium zincate here, Na2ZnO2, that is my sodium zincate, along with hydrogen gases released. Okay, so now what we see here is that when we are using sodium hydroxide, that is, we are using a base along with metal. Okay, so we are getting sodium zincate. Okay, so we are not going to get this reaction for all the metals as such, right? Okay, why? Because zinc is what? Zinc is a amphoteric metal. Now, what is a amphoteric metals? Amphoteric metals are metals that can react with both acid as well as bases. Okay, so bases will not show reaction with metal as such. Only the amphoteric metals which shows reaction with both, that is the acid and bases, they will give this type of reaction. Right, so zinc is an amphoteric metal, which means it can displace hydrogen from both acid and bases. Here, that's the reason you are getting sodium zincate in this case. So few example of amphoteric metals are aluminium, lead and zinc as such. So student, I am sure you have understood today's topic of how the olfactory indicators are used, and how the metal reacts with acid, and how we have seen zinc reacts with base as such, and what you understood by amphoteric metals. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.